A subquery is a query that's nested inside another query. They're often useful when you need to compute a value or set of values and have the result from that passed back into your main query. And when the subquery returns just a single value, we call that a scalar subquery. You can use a scalar subquery basically anywhere where you previously would have had an expression that just generates a single value. Let me show you an example where I'm going to write a query where we want to return all the films that have a length greater than the average length of all the films. So we're going to be selecting from the film table, and what we want to look for is films where the length is greater than the average length of all the films. We can use a subquery to compute that value and then return it back to the main query. And we'll select the title and the length, and let's run that. What we've obtained in our results is 487 films, and if we order by the length of that, we can see that the shortest length film we got was 116 minutes. So the average that got passed in is probably slightly less than that. Previously, you would have had to write two queries to accomplish the same thing. You would have had to first calculate the average length and then get that number and plug it into this second query. Using subqueries, we can do it all in just a single query. And you can actually pull out and just run that subquery on its own as well to see what the value is. And that's because it's an independent query that's run first and calculated a value or set of values and return that back to the main query. In dbeaver, something that's quite convenient, you can actually select the subquery that you want to run, and you can run that on its own by using the keyboard shortcut. In my case, that's Control-Enter, or just by pressing that icon in the left corner. So I'll run that, and I can see that the average film length that got passed back in is around 115 minutes. This query was actually run first by SQL to calculate the single value, and then that single value was passed back in to the main query. And that's actually why we call it an uncorrelated subquery as well. It's because this subquery has no dependence or relationship with the main query. It just got run once on its own before the main query was run, and that's it. And I'll contrast this with what are called correlated subqueries in the next video, which do have a dependence on the main query. Just a note as well, whenever you write subqueries, you always have to enclose them in parentheses. If you leave out the parentheses, you'll get an error. Because the uncorrelated scalar subqueries just return a single value, you can use them practically anywhere else in your query that you might just put a single value. For this demonstration, we've just used the subquery in the where clause, but if we wanted, we could also use the subquery in the select statement as well. Let's do another query where what we're looking at is the total amount of payments that we've received from each customer. So we're going to be working with the payment table. And what we want to do is group by the customers. And for each customer, we'll show the customer ID. And what we'll also do is sum up the total amount of money we've received from each customer. And we'll alias that as customer amount. Let's run that just to look at the state of things. So for each customer, we've summed up the total amount of money they've paid us. What if we also wanted to show for each customer what percentage of our total amount of money we've collected has come from that customer? Let's add that as another column. So what we'll do is we want to calculate a percentage, and we want to divide how much each individual customer paid us with the total amount of money that we've received overall from all customers. So we can use a subquery here to return us the total amount of money we've received overall. And we'll alias that entire expression as the percent. And what we'll do as well is we'll order the output by that percentage in descending order. So it's customer 526 then that has contributed the greatest percentage of money towards us. And customer 526 represents 0.32% of the business income. So here we just used an uncorrelated subquery to return us the total amount of money that we've received for all time, And we've used that so that we can calculate a percentage for each customer. It's also possible to write subqueries that return a single column of values, so not just one value. And when a subquery returns more than one row, then obviously that changes the operators that you can use. You can't divide by a column of values. You can't perform an equality comparison against a set of values. But what you can do is perform tests for membership using in or not in. We've already seen in and not in used previously. So we know that we could write a query that returns us all the films that have a rating that's PG or PG-13. Let's do that now. And we can use in, and we can say where the rating is in PG or PG-13. And for each of those films, let's return the title and the rating. So in has been used to check membership when we had more than one value. For situations where you don't want to have to manually list out the different elements that you're checking, you could instead write a subquery. So let's write an equivalent subquery now, where we replace this expression with an actual subquery that generates those same two ratings. And I'm going to use this left function to obtain the first two characters of the rating. And I'll say where the two most left characters are PG. Let's run that and let's see what happens. We get an error, but the only reason that we get an error in this case is just because it says there's no function called left that accepts an MPAA rating as the first argument. And that's because technically the type of the rating column is an MPAA rating. It's an enumeration. But we actually know that underneath it all, it's just text. So if we want, we can just cast that as text. And now we can run this query, and it works, and we actually get exactly the same output. And again, if you want, you can select that inner subquery, and you can run it independently. So we can see that when you run that independently, all it will return is PG and PG-13. Those two ratings that we expected, they're the only two ratings that start with PG. Let me show you a more practical example though, and in this example what I'm going to do is write a query that returns all the actors that haven't appeared in any R films. And the way you can write that is as follows. Let's start with selecting from the actor table. And what I'll do is say where the actor is not in. And what I now want to do is write a subquery that returns me all of the actors that have appeared in films that are rated R. Think about that for a moment if that's not clear. So the subquery will return me all of the actors that have appeared in R films. So any of the actors not in that list, therefore, haven't appeared in any R films. So I'll select the actor ID from the actor table, and I need to join on to a few other tables, and that's because the film information is stored in another table. So we first need to inner join onto the film actor table using the actor ID, and then I need to inner join onto the film table using the film ID. And I want to say where the rating is R. I can close that and now run this. And so there's only one actor in our database that hasn't appeared in an R film. That's kind of amazing, actually. And again, you can run that inner subquery if you want independently to get a list of all the actors that have appeared in R films. Due to the way that joins are being used, it's not going to be a distinct list, but that's fine. If you wanted to, you could add distinct up here, but it doesn't actually make a difference to our final result. Of course, there are other ways you actually could have accomplished the same result as well. For example, you could have done it using joins that we just learned about. And that's actually something that you'll find is quite common when you're talking about subqueries. So to solve this same problem, for example, you could have just used left joins. Which way you think is more clear is kind of up to you. In terms of performance though, it's not the case that subqueries will perform better than joins or vice versa. It really depends on the individual query and how the database optimizer chooses to optimize that query. Sometimes joins will be faster, sometimes subqueries will be faster, and sometimes they'll be the same. So you should really just aim to write it in the most clear, logical way possible, and then only go in and play with that query and try and write it another way if you're having performance issues. In and not in are just two of the different ways that you can interact with the results of subqueries, and you can actually look up the Postgres documentation for a topic called subquery expressions. So you can see listed here under subquery expressions, there's exists, in, not in, any, /some, and all. I rarely find any, some, and all to be useful. In almost all cases I've seen them used, the queries are better written in another way, using exists, in, or not in, so I'm not going to cover those here. We've seen in and not in, and in the next video we'll be looking at using exists in the context of correlated subqueries.